Hello friends. Hello friends. Today we are going to see some remaining topics of chapter generics. The new topic is generic interfaces. Likewise, we are having generic classes, generic methods. We can also have generic interfaces. Generic interfaces are specified like a generic classes. Now we will see one example. This example will create an interface called min-max that declares the methods minimum and maximum, which are expected to return minimum and maximum value of some set of objects. Okay. Interface min-max t extends comparable t. So what is the upper bound? Comparable interface. And type will be the type specified by t. So if you are creating object of type integer, your upper bound will be comparable that particular integer. T min, T max are two methods that must be implemented by the classes that are going to implement the interface. Now implement the min max methods. Class my class T extends comparable T implements min max T. So min max is the interface. So this interface will be implemented by class my class. Here values array of type T is created. My class T array O values is equal to O. Okay. So array object O will be initialized to value. Return the minimum value in values public T minimum. Okay. So values of 0 will be of your value V of type T. This will be written by T. Then for this purpose, starting value is for value 0. Then we will iterate to the complete array of values dot length from 1 to values dot length. If any particular value is less than this value, then V will be replaced by the values of I and then return V. Okay, so that will be my minimum value. Then T max same way. First of all, first value, that is values of 0, will be fetched from the array. Then this V will be saved over here. Then from I to values dot length, we are iterating that if values of I compared to V is greater than 0, that is any value is greater than this particular starting value of array, then it will be replaced by this value V, and V will be returned as a maximum value. Then public static void main integer I nums 36286 character chs brpw. Okay, so object is created for array I nums, C object is created for array chs. Then max value in I nums is equal to I object dot maximum value, and min value is I nums is object of I object of minimum value. Then max value is chs cob max, and min value in chs cob dot min. Output is max value is in inums array is 8, min value is inums array is 2, max value is chs as per equal to your values, ASCII values, that is w is last and b is minimum in ABCD to Z. Although most aspects of this program should be easy to understand, some key points we will see. Interface minimum maximum is declared like this. T extends comparable interface T. So upper bound is comparable interface. A generic interface is declared in the same way as is a generic class. The type parameter is T and its upper bound is comparable, which is an interface defined by java.lang. Okay, so the class that implements comparable defines objects that can be ordered. Thus, requiring an upper bound of comparable ensures that minimum maximum can be used only with objects that are capable of being compared. Okay, so comparable interface is telling that minimum maximum can used only with objects that are capable of being compared. That is why its name is comparable. Okay, and this class will implement comparable defines object that can be ordered. Notice that comparable is also a generic interface. It was retrofitted for Java generics by Java 5. It takes a type parameter that specifies the type of objects being compared. Okay, so if you are specifying T over here, so which type of objects will be compared with each other will be defined over here. If it is of integer, integer values will be compared. If it is of type float, its float values will be compared, and so on. Next, minimum maximum is implemented by my class, which is our class. This is the interface minimum maximum. Notice the declaration of my class. T extends comparable implements min max T, and this also T extends comparable T. So this type and this type are both same. Pay special attention to the way that type parameter T is declared by my class and then passed to minimum maximum. Okay. So type parameter T is declared by my class. Okay. So what is the type? T. What is the upper bound? Extends comparable T. So this is the upper bound, and this T only will be there in minimum maximum. Because min-max requires a type that implements the comparable interface, the implementing class must specify the same bound. Okay. So it's upper bound, min-max interfaces upper bound, and my class interface's upper bound must be the same. Furthermore, once this bound has been established, there is no need to specify it again in the implements clause. Okay, so when it is implementing, we have already declared the interface with the T extends comparable T interface, though in that case we don't have to write it again. Okay, for example, it would be wrong to do so. T extends comparable T we have already written here. Then while declaring the interface min max, we have already written T extends comparable T. So we cannot write it here twice. If we will write it here twice, it will give you compile time errors. Once the type parameter has been established, it is simply passed to the interface without further modification. Okay, so it is simply passed to the interface like my class comparable interface and your interfaces comparable interface, both are same and both type is also same. Okay, so next, in general, if a class implements a generic interface, then that class must also be generic. Okay, so at least to the extent that it takes a type parameter that is passed to the interface. Okay, so if your class is implementing generic interface, it must be also generic, and at least it should take up a type parameter that is passed to the interface. For example, if you are writing like this, class my class implement min max T. So if it is a generic interface min max, so your class should also be a generic class. And if your class is not generic, it will give you compile time error. My class does not declare a type parameter. There is no way to pass one to min max. In this case, the identified T is simply unknown and the compiler reports an error. Okay, so a compiler, it does not understand what is T and what you are declaring it about. So in this case, my class should also be generic and interface should also be generic. If a class implements a specific type of generic interface, class implements min max integer, it is okay. Then the implementing class does not need to be generic. Then the generic interface offers two benefits. It can be implemented for different types of data. Okay, so any type of data you can hold in that interface. It allows you to put constraints, that is upper bounds, on the types of data for which the interface can be implemented. Okay, so if your data is like for numbers, the maximum or upper bound interface should be upper bound should be class number, like this. In the min-max example, only types that implement the comparable interface can be passed to T. Okay, the only type that implement the comparable interface that can be passed to type T. Here is the generalized syntax for the interface name type parameter list. So it is the syntax, you should follow it. Type parameter list is a comma separated list of type parameters When a generic interface is implemented, you must specify the type arguments like class name, type parameter list, implements interface name, type argument list. Okay. So when you are implementing it, you must specify the type argument list in this opening and closing braces. That is the angle brackets. Now we will see raw types and legacy code. Because support for generics is a recent addition to Java after Java 5, it was necessary to provide some transition path from old to new code, from old pre-generics code. Okay. At this time of this writing, there are still millions and millions of lines of pre-generics legacy code that must remain both functional and compatible with generics. Okay. So legacy code that is available before Java 5 that is not written in with generics classes, generics method and generic interfaces that must remain both functional and compatible with the generics new version. Okay, so there should be something connecting to a code, something connecting to the code before Java 5 and after Java 5 that has the generics implemented. Pre-generics code must be able to work with generics and generic code must be able to work with pre-generic code. To handle this transition to generic, Java allows the generic class to be used without any type arguments. This creates raw type for the class. Okay. For this transition to happen, Java allows the generic class to be used without any type argument. This creates a raw type for the class. This raw type is compatible with legacy code which has no knowledge of generics. Okay. So raw type of the class, it is pre-generics and it is not known about anything about the generics class. Then the main drawback that whatever the type safety we have been used in generics, it is lost forever. Okay, only the thing is raw type. Only the thing in raw type is it is compatible with legacy code before generics, and it is having no knowledge of the generic classes and generics method. But type safety is gone. Now we will see the example of raw type in action. Class generic T. T object declare and type of type generic T. To declare an object of type T, pass the constructor, parameterize constructor TO, object is equal to O, this initialize, then return object, this object is returned and it will be returned to T. Demonstrate raw type. Now create a generic object for integers in main. Generic integer I object is equal to new generic integer 88. Now generic string object for the generic string, then raw type and give it a double value. Okay, generic raw type, new generic new double 98.6. Now the cast here is necessary because type is unknown. Raw dot get object, whatever object is stored over here, it will be converted to double and then casted to double and it will be saved to double because the type is unknown over here and this value is printed. The use of raw type can lead to runtime exception. Here are some examples. Okay, when we are using raw type, we can have some runtime exceptions. The following cast causes and runtime error. Raw dot get object to integer. Runtime error. Because raw dot get object will always return you double. Okay, because it is initialized with the double value. But since Java compiler is not known to this, it will give you a runtime error while it is running. This assessment provides overrides type safety. String object is equal to raw. Okay. So whatever string object we have created with the string value generic test is now referring to raw object which has the double value 98.6. So 98.6 is stored over here in string object and then we are converting string object to string object dot get object and storing that into string. This assignments also overrides type safety. Raw that is 98.6 is now initialized with the I object. What is the value of I object? 88. Okay. Generic integer I object is equal to new generic integer 88. So now what we are doing? This 88 is stored over raw, and then raw dot get object we are converting to double and storing to D. This will also give you a runtime error. This is also okay, but it is potentially wrong. It is potentially wrong, and this both are giving you runtime error. This program contains very much new things that you should understand. First of all, raw type of a generic class is created by the generic raw is equal to new generic new double 98.6. No type arguments here are specified like a string and integer. Here we specified integer, generic integer I object. Here we specified string, generic string object. But here we did not specify any type in angle bracket. We only specified the generic raw is equal to new generic new double 98.6. Then next is this creates a generic object whose type T is replaced by the object. So object is a base class of all types, and here in this case generic object is created with the base class as object. Okay, raw type is not type safe. So like previous to pre-generics code that we saw some examples without using generics, compiler will not know which object we are actually working upon. Object is a base class of all, but actually at compile time it does not know what is actually happening. Are you operating upon integer? Are you operating upon float? Are you operating upon strings? And so on. This raw type will also not known to this, so it is not type safe, and it will not give you any errors at compile time. It will give you errors at runtime. Thus, a variable of raw type can be assigned a reference to any type of generic object. When you will run this, you will get an error. The reverse is also allowed. A variable of specific gen type can also be assigned to reference to a raw gen object. Both operations are potentially unsafe, like regarding to type, because the type checking mechanism of generics is circumvented. Okay, generic, what is the basic advantage or main advantage is generics is type safety. Okay, it will give you errors that may occur at runtime. It will give you those errors at compile time itself. So if you are casting some incompatible types, if you are working with any type that has the bound greater than the upper bound like this, it is checked at compile time itself. But in this raw type, which is the pre-generic code we are operating upon, it is potentially unsafe with regard to type safety. This lack of type safety is illustrated by the commented out lines at the end of the program. Okay, integer I is equal to integer raw dot get object. Okay, whatever raw is 98.6, we are getting its value, casting to integer, storing to I. It will give you runtime error. Value of OB is inside raw is obtained, and this value is cast to integer. The trouble is that raw contains a double value, not an integer value. Okay. However, this cannot be detected at compile time like in generics because the type of raw is unknown. Okay, it will give you runtime error itself. Thus, this statement is fail at runtime. It will give runtime exception. Next sequence is string object is now referring to raw. String object will be equal to 98.6, and string object dot get object is stored to string. Is syntactically correct but questionable because string object is of type generic string. It is assumed to contain a string. Okay. However, after this assignment, object referred to by string object contains a double. Okay, string object of type generic string, it assumed to contain a string, and then after the assignment, object referred to by string object contains a double value, which is not allowed. Okay, assumed to have a string value but is having 98.6. At runtime, when an attempt to meta assign contents of string object to string, the runtime error results because string object now contains a double value. Okay, thus the assignment of raw reference to a generic reference bypasses the type safety mechanism. The following sequence inverts the preceding case. Raw is equal to I object. Okay, but potentially wrong. And raw dot get object converted to double stored to D. Runtime error. Here a generic reference is assigned to raw reference variable. Although this is syntactically correct, it can lead to problems. What we are doing is generic reference is assigned to a raw reference variable. It is generic I object. It is non-generic. And it is assigned to raw reference variable. And it is correct, but it can lead to errors as is stated by the second line, runtime errors. Raw now refers to an object that contains an integer object, but the cast assumes that it contains a double object. Okay. Actually, it is having the integer value here, I object, but the cast assumes that it is having the double value. Raw dot get object, here it is integer, we are converting to double. This error cannot be prevented at compile time, rather it causes a runtime error or runtime exception. Because of the potential for danger inherent in raw type, JavaScript displays unchecked warnings when raw type is used in a way that might jeopardize type safety. Okay, so what is the solution for this? Java compiler display the unchecked warnings when a raw type is used in a way that might jeopardize the type safety. So why type safety is important? Because it eliminates the runtime errors, and these errors we can handle at the compile time itself. Okay, but this is not handled in raw type. The preceding program, these lines generate unchecked warnings. Generic raw is equal to new generic new double and string object raw. Okay, but potentially wrong line. In the first line is a call to generic construction without a type argument that causes the warning. Okay, so we are creating raw type over here. Here it will create a warning. And second, it is the assignment of raw reference to a generic variable that will generate the warning. Raw reference, it is a non-generic, and string object is generic. We are passing the raw reference to a generic object, and it is potentially wrong, so it will give you unchecked warning. Okay, so by using this warning you can decide if you want to use the generic type or non-generic type, that is raw type. You might think that this line should also generate an unchecked warning, raw is equal to I object, but it does not. Okay, it is okay, but it is potentially wrong. I object is a generic object, raw is a non-generic. But still you can assign a reference of this to this I object to raw. No compiler warning is issued because the assignment does not cause any further loss of type safety than had already occurred when raw is created. Okay, when raw object is created, loss of type safety is generated at the same line. After that, no compiler warning is generated because not any further loss of type safety is generated. You should limit the use of raw types to those cases in which you must mix legacy code with newer generic code. Okay, whenever you want to have use the previously generated code before JDK 5 with the new code after JDK 5. If you want to mix both codes and you want to reuse the previous code with the new one, in that cases only you can mix the raw type with the generic type. Otherwise, you should eliminate or you should avoid using the raw types. Raw types are simply a transitional feature and not something that should be used for the new code. It is just for the sake of communication or the transition path between the before Java 5 code and after Java 5 code. Generic class hierarchy. Generic classes can be part of a class hierarchy in the just same way as non-generic class. Okay. So generic class hierarchy, like they are same as the non-generic classes. One class after that, another class after that, another class. So the generic class can act as a superclass or be a subclass of another class. The main difference between generic hierarchy and non-generic is, in a generic hierarchy, any type argument needed by generic superclass must be passed up the hierarchy by all subclasses. Okay, any type arguments needed by the generic superclass, that is main class, must be passed up the hierarchy by all subclasses. If one class is having type T, that is, this type should be passed to all the subclasses that are inheriting the current superclass. This is similar to the way that constructor arguments must be passed to a hierarchy. Like you are using the super. In super, this super must be the same line in constructor that will call the all above constructor of the base classes using generic superclass. Now, simple class hierarchy example is here. Okay, generic T object, then generic T object is equal to O, then T get object, return object. This is the simple class we have created, only the parameterized constructor to initialize and get object to get object. Then generic to type T extend generic to TO super O. This is the same way we are using super keyword like we were using in the non-generic classes in the constructor of the subclasses. Generic to extend the generic class gen. Now notice how generic to is declared by the following line: generic to T extend generic T. So type parameter is same in the both cases. The type parameter T is specified by generic to and also passed into the gen in the extends clause. Okay, this means that whatever type is passed to generic to will also be passed to gen. Generic to integer num is equal to new generic to integer 100 passes integer as the type parameter to gen also. Okay, this 100 will be passed to gen also. Thus, the object inside the gen portion of gen 2 will be of type integer. Okay, so OB inside the generic portion of gen 2 will be of type integer. Notice also that generic 2 does not use the type parameter T except to pass it the generic superclass. The OB inside a generic portion of the generic 2 of type integer, and also generic 2 does not use the type parameter T except to pass it to the generic superclass. So this type T will be used only for the purpose to pass it to the base class, that is generic. Okay, for that purpose only it will call super O, otherwise that object or that type will never be used in the generic 2 class. So what is, in short, what is the meaning? Why this T is passed over here? This T is only used to pass this value when created object is created. This value will be passed to generic T. No any other use of this T to this class generic 2. This is only for the sake of passing this value T to the class generic. Okay. Even if subclass of the new generic superclass would otherwise not need to be generic, it still must specify the type parameters required by its generic superclass. Okay. So every subclass of generic superclass need not be generic. First rule. Only superclass will be generic, and if subclass is not generic, it is okay. But it must specify the type parameters required by its generic superclass. A subclass is free to add its own type parameters if needed, like in the normal subclasses we are creating, non-generic subclasses. For example, here is a variation in the preceding hierarchy, generic T object, in which generic 2 adds a type parameter of its own. Okay, so in the generic class, generic T object, return object in the T get object, then generic class is having its own parameter V added over here, and it extends generic T, V object 2. Generic to T object comma V object 2. So super O will be called to pass this O to generic class, and OB2 is equal to O2. V is equal to get object 2, return object 2. Create an object of type generic to class higher demo. So this is my main method. What we are doing in this main method is generic to string comma integer x is equal to new generic to string comma integer. So what is string? String is for generic class, that is T. Okay. So T is for the sake of passing this string to this class. And what is V? V is over here integer. So first parameter is of type string, value is, and integer is added to generic 2. Now we will print x dot get object and x dot get object 2. Okay. So x dot get object will print this one, a return object of type string. So string will be printed, value is, and after that 99 is printed from get object to return object 2. What is the object 2 type is integer. So integer 99 is printed over here. So what is the output? Value is colon 99 and then new line is displayed using this ln. Declaration of this version of gen 2 which is shown here. Generic to T comma V extends generic T. T is the type passed to gen and V is the type that is specific to generic 2. V is used to declare an object called ob2 and as return type for the method get object 2. T is the type only for the sake of passing to gen. V is the type specific to generic 2 added by generic 2. And what is the use of V? V is used to declare an object called ob2 and as a return type for the method get object 2. Okay. So T is of no use for generic 2 for specific to generic 2 and generic T is for V is for storing the integer value and getting the integer value. A generic to object is created in which type parameter T is string, type parameter V is integer, and output is value is 99. Now generic subclass. It is perfectly acceptable for a non-generic class to be superclass of the generic subclass. Okay. Like a generic superclass can have non-generic subclass, in the same way generic subclass can also have the non-generic superclass. The non-generic class can be a superclass of the generic subclass. Class non-generic integer number, non-generic integer I, number is equal to I. This is the initialization process for the constructor, non-generic parameterized constructor. Get num will return number. Then a generic subclass. Generic T extends non-generic T object. So what is the type parameter is passed over here? It is T. And non-generic is a non-generic class, so no type parameter is specified over here. Declare an object of type T, then pass the constructor reference to an object of type T. Generic TO comma integer I. So what is T over here? T is a type parameter to generic, then integer I, super I. Okay. So this I is for the sake of calling from the basic class constructor. Base class constructor. Okay. So super I and object is initialized with O for the sake of this class, that is the generic subclass. T get object will return object. Then higher demo 2. Create a gen object for string. Type parameter string W is equal to new generic string hello 47. What is the use of 47? 47 is passed as the integer value to the parameterized constructor from the use of super I. So this I 47 will be passed over here to initialize number is equal to 47. Then W dot get object will be of type string. It will be printing hello and then number will be printed and then new line is displayed. So hello 47 is hello space 47 will be displayed over here. Hello 47. Notice how generic inheriting non-generic in the following declaration. Class generic T extends non-generic. Non-generic is a non-generic class. No type argument is required. Even though generic declares the type parameter T, it is not needed by or it can be used by non-generic. Nor it can be used by non-generic. It is first of all non-generic is a non-generic class, so that type parameter cannot be used by non-generic class first of all, and this type parameter is not needed at all by non-generic because it is a non-generic class. Non-generic is inherited by generic in a normal way. No special conditions apply. Like we are extending the class in a normal superclasses and subclasses. No special conditions apply. Runtime type comparisons within a generic hierarchy. Runtime type information operator instance of that was described previously in the previous chapters. Instance of determines of the object is an instance of a class or not. If it is instance, it will give you true, otherwise it will give you false. It returns true if an object is of specified type or it can be cast to the specific type. That is, it is compatible with the specific type. Instance of operator can be applied to object of generic classes. The following class demonstrates some of the type compatibility implications of the generic hierarchy. Okay, so runtime type comparisons we will see using instance of we were using instance of for non-generic classes. Now we can use it for generic classes also. Use instance of class generic. It is a parameterized constructor. This is a get object method. Then generic to extends generic t and its parameter constructor super O. Demonstrate runtime type information details implications of generic class hierarchy. Class hierarchy demo 3. In the main method, two objects are created. I object with 88, I object 2 with 99. String object is equal to generic test. Okay. If I object 2 is instance of generic 2. What is I object 2? This is I object 2. It is an instance of generic 2. Yes, it will give you true. Okay. So next, I object instance of generic. Yes, I object 2 is instance of generic. Okay, because it is extending the class generic. String object 2 is instance of generic 2. String object 2 is not instance of generic 2. Okay, so it is created, it is instance of generic 2 because it is created like generic 2 string object 2. Here is a question mark, that is wildcard. Any type can be replaced over here. It can be integer, it can be float, it can be string, and no upper bound is given. So string object is the instance of generic 2 is okay. Then string object to instance of generic, no, it is not connected. So it will give you false. If I object is instance of generic 2, see if I object is instance which is not. Why? Because generic 2 is a subclass of generic and it cannot refer to a subclass. Okay. I object is an object of base class. It cannot refer to the subclass. Okay. Then I object instance of generic. Yes, it is generic. Generic type information does not exist at runtime. So following line can be compiled. I object to instance of generic to integer. Okay. So this way, this will give you compile time error. Only wildcard question mark is allowed over here. Why? Because generic type information does not exist at runtime. Which type you are passing, we are not known until we are running the program. The output is I object 2 is instance of generic 2. I object 2 is instance of generic because I object is inheriting the class generic. String object 2 is also generic 2. String object 2 is instance of generic because string object 2 string object 2 is type of generic 2 and generic 2 is extending generic, so string object is indirectly instance of generic. I object is instance of generic. Okay, in this program generic 2 is a super class of generic. Generic 2 is a subclass of generic which is generic on type parameter t. Three objects are created. The first is I object, which is an object of type integer. Second, which is an I object 2, which is an instance of generic 2 integer. And third is string object 2 is the object of type generic 2 string. Then the program performs this instance of test on the type of I object 2. Okay, I object 2 instance of generic 2 question mark. Then I object 2 is some form of generic. Yes. Okay. Both succeed. At the first test, I object 2 is checked against generic 2. Okay, because I object 2 is a directly object of generic 2 and I object 2 is indirectly object of generic because it is inheriting generic. Okay, this test succeeds because it simply confirms that I object 2 is object of some type generic to object. The use of wildcard enables instance of to determine if I object to is instance of any type of generic 2. Okay, so this way we have understood the instance of operator in generic classes. Next, I object 2 is tested against generic question mark, the superclass type. Okay, this is also true because I object extends the generic class. It is a superclass of the I object generic 2. The next few lines show the same sequence and same result for the string object 2. If I object instance of generic 2 and I object instance of generic. Okay. The first if fails because I object is not some type of generic to object. Okay. I object instance of generic and I object instance of generic 2. I object is of type generic and generic is a superclass of generic 2, not a subclass. So this way it is fail, it is okay. I object is directly instance of generic class. The second test succeeds because I object is some type of gen object. Now look closely. These commented lines. Generic type information does not exist at runtime. Okay, here we are passing integer. We are not known until we are running the code that it is of which type. Okay, so this line will not compile. It will give you compile time error. As the comments indicate, these lines cannot compile because they attempt to compare I object 2 with a specific type of generic 2. In this case, generic 2 integer. Okay, so generic 2 integer or float or double, whatever type, we don't know about at compile time. We know about it at runtime. So for that purpose, it will give you error at compile time. There is no generic type information available at runtime. Okay. There is no way for the instance of to know if I object is an instance of type generic 2 integer or not. Now we will see casting. You can cast one instance of generic class to another instance only if the two are otherwise compatible. Okay, like we are casting the simple classes, those are non-generic classes. One instance of a generic class into another instance of a generic class if both are compatible and their type arguments are the same. Assuming that the foregoing program, this cast is legal. Generic integer I object 2. Okay, so I object 2 is of class generic 2 and generic 2 is a subclass of generic. So this line is okay because I object 2 is an instance of generic integer, but generic long I object 2 I object 2 is of type integer. Okay, and it extends generic type T, that is generic integer. So this line is illegal because we are passing here long. Because I object 2 is not instance of generic long. Overriding methods in a generic class. A method in a generic class can be overridden just like any other method. For example, consider this program in which the method get object is overridden. We can override methods in a generic class like any other method. Overriding a generic method in a generic class. Class generic T object, declare an object of type T. Pass the constructor reference to an object of type T. A parameterized constructor is created. Okay. Then return object, get object method, class generic 2, T extend generic T. Generic 2 T object, super object is here. Then override the get object method. This get object is return object. Now T get object, generic tools get object, return object. Okay. So what we will do in T get object, we will display this message, that is extra thing we are doing here. Here we are doing displaying this message generic get object, return object, and here we are doing generic tools get object and return object. Now we will see generic method override example. While object creation, generic I object is created, generic I object 2 is created with 99, string is created for generic test. Then I object dot get object, I object 2 dot get object, I object string object 2 dot get object. Okay, so For the base classes, it will display generic get object 88, generic tools get object 99, generic tools get object is generic text. As the output confirms the overridden version of get object is called for the objects of type generic to every time. Okay, but the superclass is version is called for objects of type generic. Okay, this is for generic, that is base object, and this is for the uh, subclass method get object and get object of generic too. Okay, so this way we have finished all the topics for today. In the next session we will cover remaining topics of generic class. So we will meet you in the next session. Thank you so much.